Quick video update on the Mendel Prusa 3D printer build. As you can see, my workbench is basically a disaster area at this point. I've been really busy, even though it doesn't look like it. The X carriage is done at this point, and that's all working great. So that's all finished. I've been working a lot on the hot end and the extruder, and the hot end and the extruder are hard. They're not super hard, but they're definitely harder than just building the bot. So you've got this heater block, this aluminum heater block that goes around the nozzle, and there's a power resistor inside there, and that's pretty straightforward. I've glued the power resistor in with black RTV silicone sealant. It turns out I probably should have used a different type of silicone sealant. The black silicone sealant is rated for 260 degrees Celsius. This is going to get up to 220 degrees Celsius on a regular basis, so that's probably a little too close for comfort. It's probably going to boil off eventually. The silicone sealant I should have used, this is the ultra black, this is what I used, and that's rated to 260. This is the ultra copper. This is the max temp silicone sealant. This is what I should have used. This goes up to 370 degrees centigrade. That would have been a better option. I didn't realize it until after I'd done it that this would only go to 260. I thought it was higher. So when that does boil off, if it boils off, I'll replace it, or replace the silicone sealant with ultra copper. So the thing that was really fiddly with this hot end was the thermistor. You've got this little glass bead thermistor, so I drilled a 1.5 millimeter hole in the aluminum block, and then I counterbored a little bit for the PTFE tubing, and I covered the leads, which the leads are very fine copper leads, and I covered those with Kapton tape to protect them, and then sleeved them in PTFE sleeving. And getting the Kapton tape around those really fine leads was an exercise in frustration. It took me hours to get that right, and I finally came up with a method that works pretty well. Basically, Kapton tape is this stuff. It's like a mylar tape, and it's got good high temperature properties, and so it's good for, you know, wrapping your leads and stuff on your heater block. And you can also use it, you can wrap the heater block itself to insulate it with this stuff too. And you also use it to print on. So you use the wide Kapton tape, you tape that down to your print bed, and that acts as a surface to print onto. So, but what I did was I would take a strip of this thinner Kapton tape and then put the thermistor leads on it, and then sandwich it between another piece of mylar tape so that it was sandwiched between the two pieces. And then I took some scissors and basically just trimmed around the wire so that the only thing, trimmed all the excess mylar tape off so that it was just down to the leads and they were covered in mylar tape. It was really fiddly and kind of a pain in the butt, but I think if I had to do it again, it would go a lot faster. It's just one of those things that you kind of have to, it's like tying flies or something. It's a pain in the butt and kind of tedious, but once you get the hang of it, it's not too bad. So those leads are covered in Kapton tape, and then they're sleeved inside the PTFE sleeving, and that'll protect them, hopefully protect them from the heat. And at least for right now, when I test it with the multimeter, it's working. So the next step for this part is to solder on with some high temp solder some wires, and then put some connectors for the thermistor and some connectors for the heater block. And what I'm going to do for that is I'm going to use these Dean's connectors, which are power connectors for RC cars. They're good. They're rated for high amperage and such. They're better than the Tamiya connectors, which are the more traditional RC car connectors. I figured these would be good 2-conductor connectors for the thermistor and the heater block. So I'm gonna, here in a minute, I'm gonna bust out the soldering iron and solder some wires and some leads on so that the and some connectors so that the heater block and the thermistor will be able to be disconnected for servicing. So the other thing I've been working on is the pinch bolt. So this is part of the extruder, and the way this works is you have a bolt that goes through this gear, and that goes through here, and then there's a an idler pinch wheel that goes on here. Let's see if I can do this with one hand. So yeah, like that. And then, yeah, it just fell out. And the idea is the filament is fed through that hole in the top, and then it gets pressed between that bearing and the bolt. So what you have to do is you have to either hob that bolt, or you have to put some teeth into that bolt so that it will it'll grip the filament and push it through. So your options there's two kind of options. One option is to hob it by using a file and cutting a groove in it, and then using an M3 and a 3.5 millimeter metric tap, and then hobbing it with a tap. Which you can totally do. You can do that with a drill. In fact, there's people that do it online. I've seen in videos doing it with the drill. I thought that was sort of imprecise, I guess. I mean, really, you have to kind of build a jig to hold everything, and then put the tap on it and spin it around and stuff. I felt like the other option that they listed was a better option for quick and dirty, and would produce good results. And what that involves is using a Dremel to cut grooves into a fully threaded bolt. So you've got fully threaded bolt, and then there's this little wheel that I've got here that's got 16 divisions on it, and I've got a little piece of copper that I'm indexing off of, and I've got a Dremel and a vise. And so you just turn the wheel and then basically cut a line into the bolt with the Dremel, and then turn the wheel to the next division, and basically that cuts some teeth into your bolt, and that's gonna, I think it's gonna grip really nice. And in fact, I think it's gonna be more grippier, have more grip than a hobbed bolt. So that's how I'm doing it. I don't have to build any jigs really. I just, through the Dremel and the vise. I did have to print that out, lasered that on the laser cutter onto a piece of clipboard material. You could just as easily print that out on a laser printer or inkjet printer. I would recommend printing it onto something that's a little stiffer than paper, like cardstock or photo paper or something like that, so it's got a little rigidity to it. That's why I decided to go ahead and do it on the laser, just for the rigidity. But yeah, that's working out really well. My Dremel battery died on it, so I'm waiting for the battery to recharge to finish that. I've got like 4 more lines to do and it'll be done. That's the dilemma with having cordless tools. They're convenient, but the battery always seems to die at the worst possible time. So once the battery's done charging on that, I can finish that up pretty quickly, and I think that's going to work out pretty well. There's an item on Thingiverse. Let's see if I still have it. Yeah. So this is the PDF file, and you can download that from Thingiverse, which basically someone's put that PDF file out there with the 16 divisions on it, so, and instructions. So you can just go there, download that PDF. It is let's see, Thingiverse, and its item number or thing number 1794 is the transport screw workaround for the Wade's extruder. And basically I just printed that out and I lasered it into some clipboard material, and that's actually working out really good, and that's going to be a real nice bolt. There's also another thing on Thingiverse that is a jig to hold the bolt with a couple skate bearings to hob it and on your lathe. And if you have a lathe, that's a good option too. The thing is, it's probably best done on a 3D printer, and since you don't already have a 3D printer, that's sort of a chicken and egg thing. You could do it out of wood or out of metal, but it probably would be a nice little project in its own right to build a little jig. I reckoned it would take me the better part of a day, and that's why I just decided to go with the Dremel method, because it was quick and dirty, and I thought would produce a very good amount of grip. So I went that route. So that's kind of where we're at with the project. Once I'm done cutting the grooves in the bolt and then the extruder, I'll be able to put that all together and attach it to the printer, and then it's onto the electronics. And I still need to, of course, solder the connectors onto the hot end, and the hot end will be done. So I'm getting pretty close now. I was hoping to have it all done, wrapped up, at least, you know, basically printing by tomorrow. That might be optimistic, depending on how long the electronics take to do. If it's just a matter of a few hours of soldering, and it's totally possible. If it's more complex than that, could be a while. Could be a few more days, but yeah, getting pretty close. So yeah, thanks for watching, and that's it for now.